Welcome to part 2 of types of radioactive decay. In this particular video, we are going to focus on beta decay. And in beta decay, what's going to happen is that a neutron is going to emit a beta particle, which is basically an electron, and it's going to change it to a proton. Because remember that neutrons are neutral, so if it's going to lose a negative charge, that means we're going to have a positive charge left over, and if it's positive, it can no longer be a neutron, so therefore it's going to be considered a proton. Some of the symbols that you'll see for beta decay is going to be a 0 over -1 with an E right here. And that 0 means it has no mass being given off, which makes sense because electrons do not have a mass, and they do have a charge of -1. So electrons are negatively charged, so we have the -1 charge here, and we have the mass of 0. Another symbol you might see is this capital B right here, which indicates beta decay because it's the symbol for beta. So those are the two symbols you'd be looking for in a nuclear reaction to see if it's beta decay. Then what changes with beta decay? Well, because we're changing a neutron into a proton, we're going to increase our atomic number by 1 because we increase the number of protons by 1. What's not going to change is our mass number. That has to stay the same. Because, for example, if you had 5 protons and 5 neutrons, and one of those neutrons is going to change into a proton by emitting a beta particle. So 5 and 5 equals 10, but now if you have another proton and one less neutron, 6 plus 4 also equals 10. So our mass number remains the same in beta decay. It's just the atomic number, the number of protons, that's going to change, and that's going to increase by 1. If we look at some examples of beta decay. Carbon-14. If it wants to undergo beta decay, you'll notice that 14 is our mass number here, 6 is the atomic number, so that's the number of protons. So if we took 14 minus 6, that would make it 8 neutrons, 6 protons. If it undergoes beta decay, one of those neutrons turns into a proton. So now we notice we have an atomic number of 7, and our mass number is still 14 because instead of having 8 neutrons, now we have 7 neutrons. Instead of having 6 protons, we have 7 protons. 6 and 8 is 14, 7 and 7 is 14. So our mass number remained the same. Then we notice right here, indication of a beta particle. So that's a beta decay. So we go from just checking it, making sure the numbers match up. We have 14 for our total mass over here. We have 14 plus 0, so there's a total mass of 14 over here. Then we have 6 as the total number of protons over here. And we have 7 with a -1. And that would also equal 6 on this side as well. So then also remember, whenever you change the atomic number, you're going to change the element. So carbon would then become nitrogen in this type of example. Then another example, hydrogen. So hydrogen mass number would be 3 in this case, and hydrogen just has that 1 proton. So it'd be 1 proton and 2 neutrons for this hydrogen atom. And then if you notice, we have the helium. And right away you might be thinking, hey, is that an alpha particle? And that would be no, because remember, for alpha decay, it would have to have 2 neutrons and 2 protons given away, and you'll notice that doesn't equal 4. So even though you do see the helium there, it's not a 4 over 2, so you know that that can't be an alpha particle. So for this one, what happens, once again, we have 2 neutrons over here and 1 proton. So one of those neutrons turns into a proton. So we got 2 protons here, which makes it now helium. And the mass stays the same because now we have 1 plus 2 would equal 3, and 1 plus 2 over here also equals 3. Here's, once again, our beta particle, no mass, just a change in the number of protons. So if we take 2 plus -1, we'd get 1, which equals the 1 over here. 3 equals 3 plus 0 over here. So all of our numbers add up and make sense. So that is beta decay.